All right, so we are in continuation of the chapter of work, power, energy, and let's see further examples related to the um law of conservation of energy. How law of conservation of energy can be further deployed in the question as well. So let's see, there's an object, its mass is 5 kg. Its mass is 5 kg, which is thrown vertically upward with an initial velocity of 30 meter per second. So let's say this is a mass which is being thrown upward, and this mass is having a value of 5 kg. And when it is being thrown vertically upward, its initial speed was uh, 30 meter per second. It was thrown with a velocity of 30 meter per second, and definitely it reaches to some maximum height. So let's call that this is our maximum height where the ball has reached. Question says calculate this height. Okay, first of all, there can be two approaches to solve this question. One of the approaches we can use the equations of motion to solve this problem. But apart from equations of motion, there can be another strategy of solving this vertical motion questions, and that is with the help of law of conservation of energy. So we know what is happening at the bottom when it was launched. Kinetic energy at this specific point was what? Kinetic energy at this specific point is maximum. And when it reaches to the top, kinetic energy at this maximum point will be zero because it is going to stop for a while. And when the kinetic energy was maximum and it was near to the ground or near to the reference point from where it was thrown, at this point, potential energy, like gravitational potential energy, will be minimum. And when it reaches to the maximum height, as it reaches to the maximum height, the gravitational potential energy is going to be maximum, right? So what, and there is no inclusion of air resistance or any of the resistive forces mentioned. So when there is no air resistance or resistive forces concept is mentioned, what we are going to take, that there is going to be decrease in kinetic energy, which will be equals to increase in gravitational potential energy. So decrease in kinetic energy will be equals to increase in gravitational potential energy. So we are going to use what formula? Half mv square is equals to mgh, right? We know from here this m and m is going to cancel out. What we are left with, हमने height find करनी है. So this height h will be equals to v square divided by 2g. And v square divided by 2g is going to give us what value? It is going to give us 30 meter per second square divided by 2 into 9.81. And as a whole, we will be ending up with an answer of 45 meters. Yes, student, tell me, is this understandable?
Yes, sir.
Yes, sir.
Right? So energy conversion concept should be in your mind. Okay, when an object is being thrown vertically upward or an object is falling downward, like let's say the counter, the next part over here, we can see this, that object of mass 5 kg is being dropped. So for instance, there is an object which is at a certain specific height, it is being dropped. When it is being dropped, so definitely it is, let's say, going to hit the ground. It is going to hit the ground. और इसका mass हमारे पास कितना है? 5 kg is its mass. और अब उसने हमें total height has been given to us. And what is the total height given to us? It is 45 meter. The total height, which is from the top level till the bottom level, this much height is given as 45 meter. You need to calculate the speed. Like as the ball is going to hit the ground, you need to calculate the speed with which it is going to hit the ground. So the speed with which it is going to hit the ground, how that can be found? So again, there is going to be what? There is decrease in gravitational potential energy, and there is going to be an increase in kinetic energy. So kinetic energy increases, gravitational potential energy decreases. अब हमने speed find करनी है, with what speed it is going to hit the ground. It is similar question जो यहाँ पर था, but यहाँ पर अब नीचे गिर रहा है. और लेफ्ट वाले केस में it was moving up. So in both the cases, let's see how it can be done. So when there is a decrease in the gravitational potential energy, decrease in gravitational potential energy is given by what formula? Mgh is equals to again half mv square. This mass and this mass cuts down. So we are left, we need to find out height. So, no, sorry, we need to find out speed. So if we need to find out speed, what we are going to do? We are going to make V as a subject. So this will becomes what? 2gh. This 2 is going to multiply on the left is equals to V square. And we are just going to take the under root. When we are going to take the under root, so this becomes V is equals to under root 2gh. Right, so now we are going to plug in the values. This is V is equals to under root 2 into 9.81. And what will be the height? The height will be 45. So we are going to solve it all, and this speed will be equals to 30 meter per second. So this is how we are going to solve for the height. जी बच्चों, is this fine? So when any object is thrown vertically upward or is thrown downward, in both of the cases, there can be two approach of finding out either the height or the velocity or a speed. What can be first approach? The first approach can be via equations of motion. तो अब इसमें equation of motion लगा के भी speed या height को find out कर सकते हो, whatever quantity is unknown. And what could be the other second methodology? The second method is using the law of conservation of energy. As we know, there is no resistive force, there is no air resistance. So decrease in one form of energy will be equals to increase in other form of energy. Is this understandable? Yes,
Yes,
please.
sir.
चलो आगे.
Yes, sir.
Okay. So moving onwards, next is going to be okay. There is another question in front of us. This is an exam question. So let's see what is being asked in this specific part. Okay, so a pendulum bob oscillates between P and R. So let's say there is a bob which is moving from point P till point R, right? Assuming the gravitational potential energy lost in moving from P to Q is converted into kinetic energy, then what is going to be the speed of the bob at Q? So we need to find out the speed at Q, right? वो कह रहे हैं कि सारी की सारी assume आप करें कि all of the gravitational potential energy is being lost and is converted into kinetic energy. So we just got to prove that loss in gravitational potential energy is equals to gain in kinetic energy. This concept we are going to use. And we have to find out the speed at point Q. So there is one point Q. So what we are going to say when the body is at point P, due to its height of y, due to its vertical height, here the gravitational potential energy is going to be maximum. And as it is rolling down, this gravitational potential energy decreases. And at point Q, the kinetic energy will be maximum. And at this point, the gravitational potential energy will be minimum. So we are just saying that loss in the gravitational potential energy will be equal to gain in kinetic energy. So let's say what will be the gravitational potential energy at this point P. So at point P, the gravitational potential energy is found from the formula mgh. And that mgh is equals to what? It will be equals to m into g. And h is, what is vertical h? Vertical h is height. That is, let's say mgy. Height is mgy. And kinetic energy, we are pretty aware about the kinetic energy. The kinetic energy formula will be equals to half mv square. So let's plug in the values. One value is this, the other value is this into the formula. So what formula we are going to get? As we know, loss in gravitational potential energy is equals to gain in kinetic energy. So this will be equals to mgy will be equals to half mv square. This m and m cancels out. We need to find out the speed. The 2 at the bottom will move to the left. It becomes 2gy is equals to v square. And to find out v, what we are going to do, under root 2gy is equals to v. So this will be our formula. This will be our speed at point Q. So correct answer in this regard is going to be C. Correct answer in this regard is going to be C. Yes, people, is this understandable how to apply the law of conservation of energy concept uh, when a body is moving
Yes.
from one point to another point? So such questions do appear in paper. Again, it's a part of a exam set.
Yes, sir.
Is it understandable? Shall I move on?
Yes, sir.
Okay, let's move up to the next thing. Okay, now we are going to see the work energy relationship when there is a presence of resistive forces. Now, what is being present? Now, there is a presence of the resistive forces. So, for example, what could be the resistive forces case is going to be there? Let's say कोई भी object जो है, it is falling in the presence of air. So, air resistance will be considered as the resistive force. And likewise, for example, if any object is falling vertically through the seawater or inside any fluid or inside any liquid, then the viscous drag, the drag force exerted by that liquid will be acting as a resistive force. So how we are going to channelize the equation relating loss in one form of energy and gain in the other form of energy. So let's witness that. So for example, we are having very first case. Okay, what happens when an object at rest is released from a height in air? When it is in air, it means there is a presence of air resistance. When it is in air, it means it is having a air resistance acting on the body. So when air resistance is acting, when it is present at a maximum point, so we can say our kinetic energy is considered as zero because it is at rest. अभी वो move नहीं कर रही. Height maximum है, तो maximum height की वजह से gravitational potential energy is going to be maximum. And when it begins to fall, there is going to be an exertion of air resistance. And when it is just going to hit the ground, its gravitational potential energy will be zero and its kinetic energy is going to be maximum. So टकराने से पहले पहले the kinetic energy है that will be maximum and at the top point the kinetic energy is going to be zero. So let's see how we can relate this whole motion in terms of equation. So in terms of equation, when it is at the top and it falls down, so your gravitational potential energy begins to decrease. So there is going to be a decrease in gravitational potential energy, and that sum of the gravitational potential energy is converted into the kinetic energy, plus the very important thing, plus some of the energy is wasted in doing work done against the resistive forces F. Are you understanding how we are going to relate the equation in this specific case? Whatever amount of energy is decreasing when we are falling downward, that decrease in the gravitational potential energy, it increases the kinetic energy plus the work done against the friction. Plus the work done, this is pretty very important, plus the work done against the friction. तो इस चीज को देखते हुए हमारे पास क्या इक्वेशन बन सकती है? Further, we can also say that the loss in gravitational potential energy will be equals to gain in kinetic energy, plus there is some heat. Why that heat is being produced? That heat is being produced due to the work done against air resistance. And now let's place their formulas. Loss in gravitational potential energy is given by formula mgh. Gain in kinetic energy will be given by half m initial final velocity square minus initial velocity square, half mv square minus u square, plus the work done against resistive force is given by the formula. Work done का हमें पता है formula क्या होता है? Force multiplied by distance. So force is going to be which force? Average resistive force, average air resistance multiplied by the distance which is covered by this height. तो हमारे पास ये एक फाइनल इक्वेशन बनेगी इसके हवाले से. आपको यहाँ से लिख ही देता हूँ कि there is a loss of gravitational potential energy which is mca, there is a gain in kinetic energy which is equal to half m v square minus of u square plus work done against the friction force into distance covered. Is this concept understandable? When there is going to be a resistive force, so what will happen? I can recall it once again. So let me recall it once again. What is happening, by the way, in this whole of the specific case? We are just witnessing, we are just watching how energies are changing when object is falling in the presence of air resistance. When object is falling in the presence of air resistance, तो air resistance की वजह से जब कोई object गिर रहा है नीचे की तरफ, तो when it is present at a maximum point, when it is present at a maximum point, its gravitational potential energy is going to be maximum. Because we know what is gravitational potential energy. It is the energy possessed by a body due to its position from the ground, due to its position in the gravitational field. This is called as gravitational potential energy. तो क्योंकि ये एक maximum height पे है तो इसकी gravitational potential energy is going to be maximum. Likewise, it is at rest initially. When it is at rest initially, so its kinetic energy is going to be zero. It begins to fall down, and as it goes to fall, when its motion begin, the air resistance is going to act on this ball in the opposite direction, right? So as it is falling downwards, there is going to be a decrease in its gravitational potential energy. Likewise, its speed is increasing, so there is going to be an increase in kinetic energy, but some of the energy will be used in overcoming the friction forces, overcoming the resistive forces, overcoming the air resistance. And that energy which is wasted will be written in the form of work done against the resistive forces. So this is how we are going to get the equation. And later we will be placing their formulas instead of loss of gravitational potential energy, it's mgh. Gain in kinetic energy की जगह आ जाएगा half mv square minus u square. And instead of heat, we will be getting the resistive force multiplied by the distance covered. So this is what a final equation is going to be stated as. Ji bacho, is this understandable?
Yes, sir.
Yes, sir.
Please speak up. Any question, anything? So shall I move on? Okay, see next case. The next case is placed at the bottom. Now, what happens when the object is moving downwards with a terminal velocity? This concept is very important. Such concept of falling object with a constant velocity. या तो terminal velocity लिखा हुआ हो या आप यूं भी कह सकते हैं कि there is a term called as constant velocity. लास्ट टाइम 2 मार्क्स का ये वाला पार्ट एग्जाम में आया हुआ था. सो उसमें यही बोला हुआ था कि an object is moving with a constant velocity, so what energy changes are going to take place, right? So when any object is moving with a constant velocity or an object is moving with a terminal velocity, so what changes are going to take place? Let's see. तो डेफिनेटली एनी ऑब्जेक्ट इज फॉलिंग डाउनवर्ड. जब टर्मिनल वेलोसिटी कब होती है, आपको ये कॉन्सेप्ट पढ़ाया हुआ है. टर्मिनल वेलोसिटी का मतलब होता है कि द रिजल्टेंट फोर्स ये तब होती है व्हेन नेट फोर्स इज जीरो. नेट फोर्स जीरो होने का मतलब क्या है कि upward force will be equals to downward force, that is weight. So this upward force F equivalent to equals to the downward force W. So when both of them are going to be balanced out, so जब भी आपके पास टर्मिनल वेलोसिटी होगी, याद रखिएगा कांस्टेंट वेलोसिटी पे चेंज इन काइनेटिक एनर्जी विल बी कंसिडर्ड एज जीरो. दिस इज वेरी इंपॉर्टेंट पॉइंट. Change in kinetic energy will be considered as zero whenever we are having a terminal velocity. There is no change in the kinetic energy because velocity constant होती है. हाफ एम वी स्क्वायर हर पॉइंट पे हाफ एम वी स्क्वायर ही रहेगा. मार्क दिस पॉइंट. जब भी कोई बॉडी कांस्टेंट वेलोसिटी से मूव कर रही है, whenever the velocity is constant, whenever the velocity is constant, there is going to be a concept of terminal velocity. There will be a concept of net force zero. Our resistive force will be equals to the weight of the object change in kinetic energy will be zero. तो इस केस में हमारे पास इक्वेशन का वाली इक्वेशन है वो कितनी रह जाएगी, that जितनी भी अब डिक्रीज होती जा रही है ग्रेविटेशनल पोटेंशियल एनर्जी, वो सब की सब किस फॉर्म में लॉस्ट हो रही है या कन्वर्ट हो रही है, वर्क डन अगेंस्ट द फ्रिक्शन फोर्स, work done against the air resistance, work done against the air resistance. तो ये बहुत important है to understand कि whenever any object is falling, and it is falling in the presence of air and in at a terminal velocity. So at terminal velocity, the net change in kinetic energy will be zero. The total change in kinetic energy will be zero. At constant velocity, at terminal velocity, change in kinetic energy will be considered as zero. So there is going to be no increase in kinetic energy. So whole of the decrease in gravitational potential energy will be converted into work done against friction. Is the second point understandable, people? So these are the two cases. This is one important case, and let's say this is another important case during the fall when there is a presence of air resistance. What happens? ये बताएं आगे क्यों?
Yes, sir.
प्लीज मुझे बाकी लोग भी अपडेट कीजिए. All of the students who are attending this session, I really request you people के please tell me, is the thing understandable, whatever we are studying and
Yes, sir.
discussing. This concept is pretty very
Yes,
important
sir.
as per the paper point of view. Okay, so I'm moving
Yes, sir.
onwards. Let's see what next I can witness. So let's apply these concept to the questions. एग्जाम में क्वेश्चंस कैसे आते हैं, ये अभी ये एक सवाल है और ये सवाल दो मल्टीपल पेपर्स में रिपीट हुआ है. This question appear in 2018 as well and this paper appear in 2015 as well. और ऐसा हो जाता है टाइम्स ए लेवल्स में दैट क्वेश्चन में माइट गेट रिपीटेड स्पेशली इन एमसीक्यूज. सो लेट्स सी, अभी जो हमने कॉन्सेप्ट पढ़ा एनर्जी कन्वर्जन का, एनर्जी इज कन्वर्टेड फ्रॉम वन फॉर्म टू अनदर फॉर्म एंड टोटल अमाउंट ऑफ एनर्जी इज कांस्टेंट. अब उसको हम न्यूमेरिकली अप्लाई करके देखेंगे इन डिफरेंट सिनेरियोज. सो लेट्स बिगिन, लेट्स सी हाउ इट वर्क्स. द क्वेश्चन सेज there is a car of mass 500 kg. So we got a mass of a car as 500 kg and the speed, and it is present at rest. So at point X, it is present at rest. On a slope as shown, the car brakes are released. So the car brakes will be released and the car rolls down the slope with its engine off. Engine at the moment is off. It means it's not accelerating further. At point Y, when it is moving down at point Y, the car has moved through a vertical height of how much? The vertical height has been 30 meter and has a speed of 11 meter per second at point Y. तो point Y के ऊपर body की speed कितनी हो जाएगी? 11 meter per second. Question says, what is the energy dissipated by the frictional forces when the car moves from X to Y? जब गाड़ी X से Y तक गई तो how much energy has been lost? मैंने आपको dissipated का word पहले बताया था. You can witness it is being used in the questions as well. The word dissipated means what? The energy which is converted to that form which is not useful to us. Like how much heat has been released in the form by the frictional forces, right? So this is actually, it means energy dissipated by frictional forces. So yes, how we are going to begin with it? We know at point X, what is maximum? At point X, we are having gravitational potential energy is maximum. And definitely when it is at rest, so kinetic energy is zero. And when it begins to fall downward, what happens at point Y? Kinetic energy is maximum and gravitational potential energy will be minimum. And during whole of this process, friction between the tires is also present. So it means some work is done against friction. right? Some work is done against the friction. So क्या equation आप use करेंगे? Equation इस तरह बनाएंगे, loss in gravitational potential energy will be equals to gain in kinetic energy plus energy dissipated due to the frictional forces. Let's call it as EF. The total maximum energy was gravitational potential energy. उसका थोड़ा हिस्सा कन्वर्ट हो गया काइनेटिक में और थोड़ा हिस्सा कन्वर्ट हो गया एनर्जी wasted by the frictional force. So let's plug in the formulas in this whole relation to find out the value of EF. We have to find EF. We have to find EF. And what EF is relating? EF is relating energy wasted by friction. How much energy is wasted by friction? So let's see how it works. Loss in gravitational potential energy is mgh. Gain in kinetic energy will be equals to what? Half mv square plus energy due to friction will be ef. Plus energy due to friction will be ef. So let's write down the values. What m is? Mass is 500. इसको मैं थोड़ा नीचे लिख देता हूँ open space में. Mass will be equals to 500. The value of g is 9.81. The value of height हम हमेशा कौन सी लेंगे? Gravitational potential energy में हमेशा vertical height ली जाती है. You may write it down somewhere on your notebook. In the case of gravitational potential energy, we always take the vertical height. So mgh, h stands for 30. This is equals to half. Mass is again what? It is 500 and v square. So velocity at point y is 11 square plus we need to find out the energy against friction. So solving whole of the matter, like this whole term will be subtracted by this whole term, and at the end we will be getting the value of EF equals to 1.2 into 10 power 5 joules. This is a way out of finding the energy wasted by friction. बेटा माहिंद, why we cannot cancel out the mass on both sides? Mass तब cancel होता है जब यहाँ पर ये EF वाली term ना हो. यहाँ पर EF वाली term present है. तो maths का आपको पता है एक relation है. Let's say अगर मैं आपके पास value लिखूं AX is equal to AY, इस केस में तो हम A और A को cancel कर सकते हैं. बट अगर मैं यूं लिखूं AX is equal to AY plus Z, अब ये वाला